be a lot easier. Plus, it gives you guys a bit of coaching, connects you up a bit, and I'm sure, like me, you're all missing seeing other people, and missing the hills like crazy. We'll get there eventually. So, what I'll do now is, get most people in. I'm gonna just share my other screen. Get it right this time. There we go. Cool. Okay, so you should now have my main screen up. Hopefully you can all see this. So I want to talk a little bit. Oh, something else to admit. Yeah. There we go. So the last talk I covered, I sort of ran through RASP, mainly covered all sorts of bits. Covered soundings, covered blip maps, covered how to use it. So I wanted to go a little bit more into detail. I basically skimmed over the stuff to do with soundings and lapse rates. So I'm going to go through some of the notes I used for my pilot lecture and explain a bit more about lapse rates, because they're, as boring as it might be, they're really crucial to what we do, how we fly, where we fly, clouds, and everything else. So I'm going to go over these points, and then if need, we'll see how time goes, because this is a 40-minute one. If you want questions, then if we run out of time, I can quickly host another one. We can join back in again and open up to questions. So let's see how we do. Let's see how fast they cut me off tonight. All right, so lapse rates. So when we talk about lapse rates, we're talking about various things. One is the dry adiabatic lapse rate, which you can all see up here, which is for every 1,000 feet gain of altitude, dry air cools by 3 degrees centigrade. And just to be clear, it's only called dry air because the moisture in it hasn't yet condensed. It's not actually dry. It's a technical term. It doesn't suddenly magically get moisture halfway as it goes up. It's always there, it just hasn't actually cooled. So when we're looking at evening, Steve. So when we're looking at thermals and what's happening, and you're looking at this, and you're looking at the RASP model, and they'll show you a particle rising, they're talking about this theoretical batch of dry air. So that will rise. So basically, yeah. So dry air will cool at 3 degrees C. So that's a dry adiabatic lapse rate, and I'll show you this. Once you've got that, we'll go to some diagrams. And oops, that. Yeah, so saturate. Now, once the air rises, once it hits dew point, it becomes saturated. So now it only cools at the rate of 1.5 degrees C. And around that, you have the environmental lapse rate, which is 2 degrees per 1,000 feet. So if we now skip down to something, and clouds. You've probably seen this rule where you can work out cloud base, but I'll come back to it. So, right, let me go down. So tepigrams. We started looking at this last time, and I just want to give you this diagram. Not that one, this one. Right. So when we're looking at this one has it's probably a bit clearer than what I used before. So the blue line here is the environmental dew point. This is where they've done a sounding, they've taken measurements, and this is what they're predicting the actual dew point will be at different heights. The red line is the environmental lapse rate. That's this one. And so that's, again, this is the predicted actual temperature as you go up. Here, the dotted line is our predicted thermal. So at this point here, salt presented. Okay, hi salt. Saba. People arriving late. So down here is our theoretical parcel of air, our dry parcel of air. This will start to rise, and then it saturates, and it goes up at the saturated rate here. It cools at this rate, 1.5. So let me go back to one of these other ones. That one. This one. So this is like a zoom in at that point. So here you can see we've got this point down here is our parcel of air. It's rising. This is dew point. It follows that line of temperature. At this point, it condenses. You get clouds. It now goes at saturated, and it rises up here. So it follows that rate. So if I just pick out this one. Sorry. All right. Sorry. Yes. Yeah, so so where they meet is the cloud base, and that's the cloud top. So that gives you your height of clouds. Now, so it's a couple of basics then. So any thermal will continue to rise if its temperature is equal to that of the surrounding air. So I'm going to flip back to, so your cloud will build until saturated adiabatic meets the environmental line. So I thought this diagram was nice and clear. I'm not entirely convinced it is. I'm going to go back to this one. So basically, this is our parcel of air. It's now cooling, 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 cooling. At this point, it reaches the environmental air temperature. So because it's now the same temperature, it cannot rise. It just can't. Air rises because it's as long as it's warmer than surrounding air, it goes up. At this point, it stops. So that's the top of your cloud layer. Right. Okay. So let's go back to this. Right. So that's just the basics of thermals, and it's the basics of soundings. So now I'm going to flip to RASP, and I just want to go through some extra features on this, which I didn't really cover last time. And basically before, the main thing I looked at was the compact version, and it was and just these points here where you get soundings. Now, to get more detail, if we come back to our menu, and down the side, we've got various other ways and various things we've got. We've got custom soundings. And this is where you get them by BGA term point, which is the British Gliders Association. Someone's probably going to correct me on that, but I think that's what it stands for. So now, rather than just being restricted to those few ones, you can actually get your soundings based on any of these term points. So if we wanted to go at, rather than Hurst&So, if we wanted Devil's Dyke, we can come here to our by term point, we can find Devil's Dyke for today, DDK. So I'll dig up in a second. There we go, Devil's Dyke. So today, Thursday, let's see, and click get results. Now, if you do use this, there's a slight glitch on this, which it doesn't actually show you the damn thing properly. So the way you get around that is you right click on it and just open it in a new tab. So here we now have the sounding for earlier today. And weirdly, it's showing no thermal activity. It's so tight to this line. Let's see what happens a bit later in the day. Let's go get later in the day, make it up to 2 o'clock. Here we go. Okay. So now this was it at 1 o'clock. So here, because of the environmental lapse rate, you'll be pleased to know there was no thermal activity at that point. Nothing. Here we are a bit later in the day, and you can see, if you look at the dotted line here, so now it's starting to get very weak thermals just starting to occur. So these were just going up to base at, would have been at about there, about 2,000 feet. Okay, got those. So this allows you basically to go in and extract your soundings for most places in the UK. If you want to know where these are, you can get them listed on the website, but if you come down here on the left to the BGA turn point map, what you get is the BGA turn point map. So you can now, if it's somewhere you're interested in, you can click on one of these and you'll get what the code for it is. So if you're planning a route, here we've got Truly, should be Devil's Dyke, Ditchling. So you could jot these down and you can actually see there's Ringmer, that's Heathfield. So you can actually check your sounding as you went along. So let's do a theoretical thing for tomorrow. So we'll take a look at Devil's Dyke, and then we'll take a look at Heathfield and see what's happening on those. So we go back to our custom soundings, and we will put in, bring it up quickly, D for Devil's Dyke. Okay, Devil's Dyke, here we go. Let's have a look at tomorrow, see what's happening. So we'll take it around lunchtime, results. Open new tab. And then as a comparison, I'll just pull up the Heathfield one as well, which was HEE. There we go, Heathfield East. Friday, 12 o'clock, get results. It's still Devil's Dyke there. Now we've got Heathfield, you can see it at the top, it's telling us where it is. Open a new tab. So you can actually, so now you can get a comparison of what's happening. So it doesn't look great. But basically there's nothing lower down at that time, there is no thermal activity occurring. At Devil's Dyke, nothing occurring further inland. So out of interest, I'm curious to see what's actually happening with the weather, the overall weather tomorrow. Sorry, bear with me a second. So we go to our compact viewer. We'll take tomorrow, Friday. So it's showing Friday, lunchtime, full parameter list. See what's happening with the wind. Okay. And if we have a quick look at thermaling height. Okay, yeah, so it's fairly pants. Not a great day for lots of flying, which is kind of good, but we're still getting rubbish days for flying. Right, let's go back a bit. All right, so basically you've now got, so you can extend how you use RASP for picking out your, you could basically take the various turn points along your route. You could set these up and you could get a comparison of what's happening on your flying route at different times. So you can figure it out. All right, so, and back to this one quickly. Right, so it's gonna, I was kind of hoping the forecast was slightly better, so I can give you some practical things on this, but we'll go back to this theoretical. So what I'll do, right, So basically, when you're using this,
Saturday looks slightly better.
Does it? Okay, brilliant. Let's pull up Saturday. Let's have a look at that. I could do with one that's actually showing some sort of activity. Thanks, Andrew. Right, so let's go back to our custom soundings. And let's bring up Saturday, 1 o'clock. Let's look at the dike again. And let's see what we've got. Okay. That one. Right, here we go. So 1 o'clock Saturday, get results. Okay. Tab. Right, let's see. Ooh, well,
maybe not.
Maybe not. Okay, well, let's take a look at this. What do thanks, Andrew. I don't know where you're flying, but well, not mine. But what we actually see here is still take a look. So a parcel of air leaves the ground. It's because of this gradient, it's actually not, the thermal strength is actually very weak until it gets here. So, and we're probably going to get base, if we draw through this, probably around here somewhere. And then what we now see is this, it's traveling up on the saturated line, and that's look at where that's going up to. So that's giving us clouds up to about 18,000 feet. So you'd be in a situation where, should you have managed to get a climb and worked your way up to here, you're suddenly going to find you're in a lot of instability. And this, sorry, I'm just letting people in as we go. Right, so what you'd see here is that the dotted line doesn't show, because it's actually running parallel to the lapse rate. So there's virtually no thermal strength there at all. When you get to here, you can see the gap widening, which means the thermal strength here is increasing, is getting stronger. Let's just pop back.
John, can you please look at the wind direction on that one?
Yeah, I'm just going to bring it up now. I think we'll do it. That we'll start with. Let's bring up that one. It was Saturday, wasn't it? We were looking at. Okay, so let's bring up switch to full parameters. Now let's get the surface wind. So we've got at lunchtime, right? So you've got very weak wind activity. So you might want to, it's sort of light southeast. I mean, it's not strong enough to be on the coast. It's, I guess you could get tow launch, but then there's not enough thermic activity to do anything once you've been towed. It's just like a normal crap Easter weekend to go flying with. Except you've been waiting for Easter. It's rubbish. So let's have a quick look at on this one where it talks about thermaling height. Where are we going with thermal height? All right. Well. So maybe if we look at, so round here, crap. But let's pick out a turn point near Oxford. So what have we got? What's one of the Thames Valley ones would be? I don't know those off the top of my head. Let's find out. So let's go back to our BGA map. It obviously looks better there. Let's find a turn point in that area. What we've got here would be around. Okay, well, there's devices. Pews, there we go. PEW. We'll go with that one. That's not far from Milk. So we'll come back to our custom soundings, and we're going to whack in PEW. So Pusey, and we're looking at for Saturday about 1 o'clock. Get results. So we should see slightly different situation. Open image in new tab. Right. Okay. So now here we've got a distinct, albeit slow, but here we've actually got thermal activity occurring. We've got a gap. It's not a lot, very weak climbs, up to, again, about 4,000 feet. But, again, massive overdevelopment up to about 20,000 feet. So it's, with that much instability going on, it's not a good day to go out flying. You know, you risk getting pulled in, because this keeps going. This can build into QNIMs. You know, you're already up to what, 20,000 feet. It could just keep going. So it's the sort of thing where you struggle to get up in a week climb. You get up to base, and suddenly you're like boom, into cloud, and you're gone. So if we look at, we'll just take the same one. I mean, that's, you can see the overdevelopments there, but we don't have the initial climbs here. If we pop back to our compact view again, and Saturday, parameters, thermal height. Yeah, so look at what's happening. 2 o'clock. So now we can see it overdeveloping and breaking up. And if we look at, throw the wind into that, again, almost, it's a very light wind day. I suspect, let's have a look what it thinks. Star rating. Well, see, that's interesting. You look at the star rating, you might go, hey, it's a cracking day. Doesn't actually bear out when you look at the soundings and you look at the nature of the clouds. You'd be pretty cautious about flying in that, I think. Well, I would be anyway. So out of interest, if we that one, let's quickly bring up. Let's see for where was that? It'll be there somewhere near. Forgive me, Fusey. Forgive me, Fusey. Wiltshire. Fusey, Wiltshire. And let's look at Saturday. So what do we have? We have yeah, so light southwesterlies, sunshine. Here, like cloud cover. Interesting. And if we, the other thing I would look at then to get a better idea of what's happening is if we take the synoptics for the day, charts, come on, maps and charts, surface pressure charts, and here we are, Thursday. So what have we got? Okay, Friday, Saturday lunchtime. So we've got a high pressure system here that's been pushed out. We've got basically we've got surrounded by these high pressure systems with a low pressure system coming in. So that's going to account for the type of weather that's occurring. Probably nice and sunny, probably quite hot, not great for flying. Oops. All right.
So the high pressure is causing this stability, is that right?
Yes, that's correct. It's not, interestingly, normally with that, I suspect, I would expect, normally you get a bit more of an inversion with high pressure, which if we take a look at, back again, if we bring up a, let's see what's CT for that one, we don't really see any sort of marked inversion here. So it's, I think this instability is from the bit of low pressure that's pushing in as well. That's out of interest. If we go slightly later in the day.
Where's the air mass from?
Let's have a look. We've got on that day, if we go back one day, let's see how it's building. So we've got on Friday, we're distinctly under this high pressure system over, what's that, sort of between Sweden, Denmark, that area. That's definitely affecting it. If we look at how it's moving, you can see the air mass is coming in from, I would say, looking at these ones, I don't know, Steve, what do you reckon? I think we're getting some sort of northwesterly air mass, it's almost a bit of the sort of that Arctic maritime, off the top of my head.
Yeah, that's for after the front's gone through. I mean, when the high pressure's in charge, it actually looks like it's tropical continental, which will also explain why it's fairly inverted.
Yeah, that would make sense because of these. If we go back a day, it's being dominated by these high pressure systems here, which will be coming up from this direction. Cool. All right, good. So let's see what we'll do. I'll have a very quick look at the net. I just want to see if the weather actually, see if we can find a day on here. It looks vaguely okay. Let's just quickly put in local to us. Let me go. Truly. I prefer Truly to Brighton because it's taking it a little bit more inland. So we've got Sunday, a little bit of rain, otherwise southwesterlies, overcast. Monday, so that's interesting. So Monday we see we're going to get blown out northeasterlies. So we'll have a quick look at this. Then we're getting really strong easterlies coming through. It really is crap weather. So if we take a look at, let's see what happens on Sunday. We would expect to see overcast weather. We would kind of expect, if we go to our custom soundings, Devil's Dyke, a lot of like I would expect to see the environmental lapse rate and the dew point meeting to give us a lot of cloud cover. So let's bring that up. Devil's Dyke. And Monday, again, get results. Here we go. Image in the tab. Let's have a look. Oh, no, I'm wrong. But, okay, so here we've got a massive inversion. And quite a low, so we're getting a low base here at about 2,000 feet. Reasonable therming activity up to that point, and then very little after that. So in fact, for this, looking at this, we would expect to see basically sort of what, not quite what the forecast shows of like really overcast, but more smaller, fluffier type clouds. But that's a great example of an inversion, and you can totally see how there it's going to get here, and you're going to have not going to have big clouds at all, but a low base. So we've got. I'm being prompted by Zoom that we're down to about another 10 minutes. I'm not going to upgrade now, Zoom. If anyone's got questions, let me just. You should be able to unmute yourselves, I think.
You can just use spacebar as well to talk.
Great. So if you're on that, hold your spacebar and you can talk. That should. Someone wants to try it. I'm going to just stop sharing for a second so I've got everyone on the whole screen. So I can see what's happening then. And participants. Excellent. So if anyone's got anything you want to ask, go over it. I'll see what I can attempt to answer in a few minutes. As Magius was to give a quick update on this. The other thing I'd be interested to know is if you, not now, but stick it on the coaching page, any feedback on topics you want to get covered. I'm trying to get someone to do one on instruments for you. That's not, even though I use instruments aren't my forte at all. So if anyone feels up to doing a talk, if they have a specific instrument you want to do one on or presentation on, let me know. Other than that, anything else you want to cover, give me some feedback. It helps. So I'm just going to. Okay. Right, I thought I'd unmute everybody, but I won't. So you can unmute yourselves if you want to ask a question.
John, can you show us a sea breeze on the diagrams?
Can I show you a sea breeze? Let me see. I've got. Let me go back to my Met one. Let me find one. I can give you fronts and stuff. Give me 1 second. Let me screen share again. Okay, so fronts, warm fronts, including fronts. Where have my sea breeze? Oh, there we go. I can show you how this is how a sea breeze forms, if that's what you're asking. Again, it is down to pressure differences. You've got the classic sea breeze is this, where you've got sun on the land, it heats it. Because the air is rising, you get low pressure. This creates this, obviously, it rises, it goes out over the sea, it will now descend. It's cooling down, descending. Because air is descending, you get high pressure. It's just important, it's a very basic concept. If air is going up, rising air is low pressure, descending air is high pressure. So we've
John,
now
got on the sounding.
Oh, on the sounding. Whoa.
Yeah.
Okay. Oh, well, let's have a look. Sorry, I thought you wanted to know how it worked. My mistake. Right. If we go back to this, what you can do to get an idea of sea breeze effect, your best bet rather than soundings is actually to take a look at convergence. Normally what you see, good, not boundary there, sorry, switch to full parameter, where's my convergence, convergence. Yeah, no, it's a convergence one. Usually with convergence, you can actually see, it's not very good on this one. Let's pick a different day. Let's have a look. Saturday. What you'll normally get along the coast is you can actually see where the sea breeze is coming in, but I need a problem is if it's not there, you can't see it, quite simply. But let's find one.
Could you see it by the wind arrows down the right-hand side?
It's difficult to tell because normally for sea breeze effect, you look at this map, you go to convergence, and what you'll see are, it's not there, I can't show it. I'm trying to find a good day where it's actually got it on there.
I think because we've got lots of southerlies in the future that you're not seeing. Yeah.
Yeah, this is the sort of thing you'll get where if we take this day, you'll get this line, this CCO line running along the coast here. This will normally, you should see that. Yeah, no, it's not moving in well enough. What I'll have to do is once we actually get a sea breeze day, I'll save some diagrams to show you how it works. It's one of the things, if it's not there, I can't show it, basically. But the classic, but Andrew raised an interesting point, which is the way we get your classic sea breeze occurs when we've got northerly winds, not when we've got southerly winds. Not that you don't get a sea breeze in a southerly, but the effects of it are more dramatic when we have a northwest wind. So you've got northwest wind blowing down, sunny day, heat builds over.
Oh, we've got less than a minute.
Less than a minute. Okay. Let's see if I get cut off. I wonder if they'll let me go on for a bit longer. Right. If do you guys want to ask some questions? I can quickly throw up on. I can create another meeting if you've got more questions, or we can leave it there. We've got about 30 seconds.
Yeah, go on, create another one. It's fine.
Okay.
We come back in 5.
Yeah. Okay. What I'll do, if I dump it on, if you check Telegram, I'll create it, drop it on there. I'll stick it on the coaching and the para chat. You'll have it there in within a few minutes of this one finishing. All right.
Cool.
Cool.
See you in a bit.
See you in a bit. Less than 1 minute.